Discontinuity, that is a fancy way of saying is a function continuous. Okay, so we have to talk about classifying discontinuity. So a discontinuity is a location where the graph is not continuous. Right, so we have different discontinuities. They are either removable or non-removable. All right, so those are your two big categories. If it is removable, it means that the two-sided limit exists, but there is a hole. So if you look at these two pictures, I can find the limit as x approaches 1, but it's a different value than the actual filled in dot. All right, this one I can find the limit, but there is no value there. So we call that a removable discontinuity. The holes are removable discontinuity. The non-removable are either a jump, which means the one-sided limit exists. So I can find the limit from the left, I can find the limit from the right, but those things are not equal. The graphs don't come together. If you have to jump off to get to the other piece. Okay, so that's why it's called a jump discontinuity. The other non-removable is infinite, which means there's an asymptote. So at least one of the one-sided limits doesn't exist. So one of the graph is going to infinity, or it could be that both are going to infinity. So this would be a non-removable discontinuity. Here, only the right side is going to infinity. The left side is stops, but this is still a infinite discontinuity. All right, sometimes multiple choice questions will ask, what type of discontinuity does this graph have? And you have to say removable, non-removable, things like that. So you do need to be familiar with those definitions. All right, definition of continuity at a point. So if I ask you, is f of x continuous? You have to check these three things, and you have to show that you're checking these three things. All right, the first thing is that f of c is defined. So if I want to find is f of x continuous at x equals 2, I'm going to find f of 2. If I get a number, then you've checked off that one. It's defined. If there's a hole, if it's undefined, then you're done. It's not continuous. If it is continuous, you go to the next, or if it is defined, you go to the next. If you find the limit as x approaches 2 of f of x exists, so what does that mean? The limit from the right is equal to the limit from the left. That is the second thing. And then the last thing is the answer you got here and the answer you got here have to be the same. So if f of 2 came out to be 3 and the limit exists and it was 3, then you've met that quality, that the third bullet point. All right. If f of 2 is 3 and the limit is 5, then it's not continuous. All right, we're going to go through some examples. Definition of continuity again is just on the same page so you can see it. So what is my definition of continuity? F of c is defined. I'm just going to put the limit as x approaches c from the right is equal to the limit as x approaches c from the left. So that's basically saying the limit exists. And the last thing is that f of c is equal to the limit as x approaches c. Okay, so we have a graph of f of x and we're going to fill in this table. So first, we're going to start at x equals 9. X equals 9 is over here. Find the value. So I want to find what is f of 9. F 3.5. What is the left-handed limit? Oh, I guess that's, I don't know. What is the left? So as I approach from the left, what is the limit? Yep. Yes. But if we answered this to be 3.5, let's say that this is 3.5. What about the right side? There's no graph there, so what do you think the limit is? Does not exist. So what would the overall limit be? Does not exist. So is f continuous at x equals 9? No. Maybe we'll do one more together and then I'll give you a few minutes to try to fill in the rest of it. Let's do it 0. So let's do the one at x equals 0. If I can't see it, so f of 0. What is f of 0? 6. What is the limit as x approaches 0 from the left? 6. What is the limit as x approaches 0 from the right? 6. What is the overall limit? Whoops. Is it continuous? Yes. Okay, we've checked, we found the value of the function. F of 0 is defined, the limit exists, and those two values are equal. So the answer is yes, because f of 0 is equal to the limit as x approaches 0. All right, I'm going to give you, I don't know, like 3 minutes to fill in. Try to fill in as much as you can. Like when it's one.
Yo, actually goes like where everything's like. But that can be continuous. So, yeah, everything's on the con. Oh, vaccine before the special case. You get off. Maybe like nothing.
What?
So. You can take them in.
You write a limit as
If it's a one-sided limit, you can answer it as infinity or negative infinity, yes. Or you can say it's the they're the same things, they're interchangeable.
I will choose for the experts. First, I'll be.
Obviously, and then. Everything's no until it's actually zero. There's the nice. No, before it's low.
On different split.
At that continue, there's like point, but like.
Yeah, but, I've never heard of that. It's like, are you?
Limit.
No, we're through 10 hours of that day. You got what's that?
All right, that's my time. Started filling them in, so if you want to check to make sure, and I'm gonna, for time's sake, stop writing the notation, but, where am I? Three from the right. Okay, so when you look at the graph, there is like a gap. Oh geez. I didn't know. Whoa. So this gap right there means that if I'm approaching 3 from the right, not the left, from the right, there's no graph to be on, so that limit doesn't exist. So there's really only a one-sided limit at 3 because of that graph stopping. All right, questions about 4? All right, and then at -3, I'm just gonna put the answers here. So f of -3 is -6. The limit from the left is 5. The limit from the right is 5. The general limit would be 5. But this is not continuous. And the reason it's not continuous is because f of -3 does not equal the limit as x approaches -3 of f of x. I can't write. I can't write anymore. Yes. So you are, if it's not continuous, you have to tell me why using of those 3 bullet points.
Okay.
Okay, so why is this one not continuous? You can answer, because the limit as x approaches 9 does. All right, this one, you could answer because f of 4 is not defined. You just have to give one of those 3 bullet points as your reason, yes. Yes. If you answer no, I need to know out of those 3 bullet points, why is it not continuous? And if there's multiple answers, like if the limit doesn't exist and the function's undefined, then you can answer either one of those. And if it's yes, your work should show that you verified all 3 things. Correct. All right, and the last one, the function f of -5 is -2. The left limit is -2. The right limit is 7. So your overall limit does not exist because the right does not equal the left. And then is it continuous? No. Yes. So if the questions are, how are we supposed to properly answer the question? Okay, so how do we properly answer the question? If I ask you if a function is continuous, then if the answer is yes, your work better support. So you better tell me what f of the function is, like what is the value, what is the limit, and show that they're the same. If the answer is no, it's not continuous, I need I need one of the, like, you can't just say, no, it has a hole. No, it has an asymptote. That is not a correct answer. It has to be one of these 3 things. Okay, is the reason for it being no. Yes.
On a full test, we have to carry the box for like.
Well, it's like I said, it's not gonna be like a table like this. I'm just gonna give you a picture and say, is f continuous at 3? And you're gonna go through, so this was just kind of guiding you through the process that you're gonna have to take to find the answer. Okay, so next, to determine if a function is continuous by looking at the equation instead of the graph, you're going to consider its domain. So if we look at these 2 examples and determine if the discontinuity is removable or not. Okay, so we're going to use some kind of prior knowledge. So this one, what is your domain? What can x not equal? 0. Because we have a fraction, denominator can't be 0. All right, now I want to know what's happening at 0. So I'm going to factor this. And I can cancel out that 0, right? Or I can cancel out the x and be left with x plus 3. So what is happening at 0? It's a whole, right? When you take a rational expression, if you factor and cancel, the thing that cancels is a whole. So this has, so f of x has a whole at x equals 0. So is that removable or non-removable? Because what does this graph look like? X plus 3. It's a straight line. So basically, if I was going to graph this, I'd start, have a, it would look like that. So does the limit exist? Like you can find the limit from both sides, so that's why it's a hole, and that's why it's removable. All right, you want to try the next one? So I'm finding my domain. And then I want you to. I have a different. Oh my God. Okay, so when I factor it, I can cancel out those X plus 4s. And so there's a hole at X equals -4, so it's removable. All right, questions on that? Ask me what? Yep. How would I graph that? So again, what's left is an X minus 2. So that starts at -2 and has a slope of 1. But at -4, there's going to be a hole. Okay, so what is left after you factor it is what the graph looks like. But there still is that restriction in the domain. So there is still a hole there. Okay, continuity and piecewise functions. To determine a value that makes a piecewise continuous, you must make sure that each piece of the graph at the break, where the inequality is, that each of those pieces have the same y value, that the two pieces come together. And we have to do it using proper math. Okay, so here is, I gave you f of x is a function. It's 2 linear pieces. The break of the graph is at 1, and I want to find the value of b that will make the function continuous. So I basically want those 2 lines to come together. Well, using our definition of continuity, is f, where are we checking if its continuity is at 1? So is f of 1 defined? Is there? Yes. Okay, so that's our first checkpoint. The second checkpoint is that the limit exists. So because I have a piecewise function, I need to find the limit as x approaches 1 from the right of f. And that has to equal the limit as x approaches 1 from the left. So which piece is on the right? That would be the greater than. So I'm finding the limit as x approaches 1 of 3x plus b. That has to equal the limit as x approaches 1 from the left, which is -2x minus 10. A lot of you are just plugging 1 in and seeing if they're equal, which is what we're gonna do, but you do need to show that limit first. So when I plug one in for X, I get 3 plus B. That has to equal when I plug one into the other piece, what do I get? -12, so what is B? -15. Sometimes there's multiple pieces, like there might be a third equation. So you have to set, the first two pieces have to equal each other, and the next two pieces have to equal each other. So you would have to set up two different limit things. That's on the classwork, so. All right, questions about definition of continuity before we move on to our theorem IVT? Our next big theorem, intermediate value theorem, which we usually abbreviate as IVT, intermediate value theorem. So what does it say? If F is continuous and K, which is a number, is between F of A and F of B. So F of A and F of B are Y values. Okay, so I have some Y value that's between two other Y values. Or it could be flip-flopped, like F of B and F of A switched. Then F of C will equal K between A and B. What? I'm going to draw a visual. Hopefully it will make it easier to understand. Where can I draw it? I'll draw it here. All right, so I have some function F. So I'm just gonna. That's F of X. Then I have, this is A, and this is B. Okay, so my interval goes from A to B. So over here, oh, I did it. I'm gonna just make this one a little bit lower. So this would be F of A. Right? And then if I plug in B over here would be F of B. Right? F of A is the Y value when you plug in A, and F of B is the Y value when you plug in B. If I have some K that's between those two, so between here, I put in a K. The function will equal that at least one time. So F of K exists. So like right here, at that C, if I plug C into F, I get K. I'm going to try to make it make a little more sense using zeros. If you have a function that is continuous, so that's the first thing. If F is continuous, the function has to be continuous. And one of the Y coordinates is negative and the other Y coordinate is positive. Will the function cross zero? Yes. That's what IVT is saying. Okay, if your function is continuous and you have a value here and a value there, you're gonna cross in the middle because you can't connect two dots without hitting that middle line. So remember way back when you used the TI calculator, maybe in middle school, and you had to find zeros and you had to do left bound and right bound, you got to do one above and one below to get it. That's IVT. Your calculator's doing IVT. So. Okay, this theorem is used to prove a certain y value exists on a function. The common application is a zero of a function. The use of this theorem is structured in the form of form of a sentence in most cases. Usually it will ask, is there a value or it might say, is there where f of x equals some number? That means use IVT, use intermediate value here. They won't say use IVT, like our example said. Okay, so you're gonna have to remember this theorem in May and how to use it. That's why we don't memorize, we understand what's going on. Because if you understand, then you're gonna be able to apply it. All right, so usually it won't say use IVT. But our examples do. To show that this function has a zero between f of -4 and f of -2. So I'm going to show you how you're going to set these problems up. So the first hypothesis is that the function's continuous. What is f of x? What is that a graph of? A parabola. What is the domain of that function? All real numbers. So is that function continuous? Yes. So we're just going to say f of x is continuous. And the next thing that has to be true is that the y value you're trying to find is between the other two y values. Okay, so I'm going to kind of go off to the side here and find what is f of -4, and I'm going to have you guys tell me, and what is f of -2. So take -4 and plug it into the function. Take -2, plug it in the function. Did you already get it? -25. Did somebody plug in -2? You guys can do mental math faster than me. 3. Anyone verify, or are we just waiting for
Yeah.
somebody to do it for us? I'll look at, that's what I had to. All right, so is 0 between those two? Yes, so f of x is continuous, that's hypothesis number 1. Number 2 is that 0 is between, now which one's smaller? -25, so is between f of 4 and f of -2. So what does that mean? By IVT, f of c will equal 0 on the interval from 4. Oh, that should be a -4. Sorry. Did somebody just say that? On the interval from -4 to -2. Those of you that are struggling, here's a picture. -4 is here. F of -4 is -25 down here. F of -2 is 3 right there. Since F is continuous, I have to cross 0. Are there more examples? Ooh, lots more, man.
Are we just taking that it's continuous of the interval?
It didn't ask us to find it, did it? Yeah, it didn't ask us to find where,
That one we just say that there is value.
so there is a value, yep. All right, apply IVT if possible. On the interval from 0 to 5, so that f of c equals 1. So f of x is, domain is all real numbers, so f of x is continuous. And what's the next thing we have to check? What's f of 0? -1. What is f of 5? 29? No.
Yes.
29? What number has to be between them? Not 0. 1. Why, what are we trying to find? We're trying to find if the function equals 1. So f of x is continuous and 1 is between, which one's smaller, f of 0? F of 0 and f of 5. So by IVT, f of c will equal 1 on the interval from 0 to 5. Or between 0 and 5. Is that, they want us to find it yet? Let's go ahead and find C so that you have an idea. Yes. So to find C, that means you'll just take the function f of x and set it equal to 1. So in this problem, if I do, instead of x, I'm going to say c squared plus c minus 1, that is equal to 1. And then you're going to solve that quadratic. So if I bring that over, c squared plus c minus 2 equals 0. What is that factor? C plus 2, c minus 1. So I'm finding what c is. So c is equal to -2 and c is equal to 1. Are both of those answers? No, why not? This is our interval, so that is not on our interval. So the answer would be c is equal to 1. Again, a visual. If I have 0, I'm at -1. 5, I'm at 29. Here is 1. When x is 1, the value f of x is, this is a parabola, I don't know what it would look like. That's not very good for Ella, but you get the idea. So at 1, your function crosses. All right, what's the domain of a cubic function? Yep, all real numbers, so f of x is continuous. I need to find f of 0 and f of 1. I can do f of 0. What's f of 1? 2. And what am I trying to find? A 0. So is 0 between that?
No.
It is. What are you scared to ask me? What? You can ask me. Okay, so College Board doesn't like to give you functions. They like to either give you tables or graphs and ask you questions about it. So it makes it easier because you don't have to like plug in numbers because they're giving you the numbers. So this example gives you a table. It says the cars traveled on a straight track during the time interval from 0 to 60 seconds. The car's velocity is measured in feet per second and is a continuous function. The table shows select values. So for the interval from 0 to 60, must there be a time where v of t equals -5? So do you see how they're asking, like, must there be a time? Is there a value where the function equals -5? So we're going to look at the table, and can you find two y values that -5 is between? Which ones? -10 and what? 0, right? Could you have used -10 and 10? Yes. Is there any other ones? Could you use -20 and 0?
Yeah.
Yes. So you just have to find two places where -5 is between. So must there be a value? Yes. And justify your answer. So v of t is continuous. And -5 is between what two values? Let's use v of 35 and v of 50. You can use different values as long as -5 is between them. Yes.
Is it not continuous?
When is it not continuous? So if the function they give you is a rational expression, where you have a fraction and the denominator can't be 0. So if you had 1 over x and 0 was in the interval, that function's not continuous. So like 1 over x. So if I have this and my interval was like -1 to 2,
Okay.
that function's not continuous on that interval. So IVT may or may not work. Okay, so you do have to be careful. All the ones I've given you have been continuous. All right, we have one last example. Use IVT to show For all spheres with a radius from 1 to 5, there is one that has a volume of 275. And they gave you the volume of a sphere in case you didn't know. But this equation again is a cubic function. So I'm gonna find V of 1 and V of 5. So if I plug in 1, I'm gonna get 4/3 pi. Can somebody have a calculator handy? I might have it as I have it as a decimal. It's 4.1888. If I plug in 5, that's 125 times 4. 500. And that is 523.599. All right, so it's 275 in between there. Yes, so what do we write? We say since V of R, it's V of R because my other variables are, is continuous. And V of 1 is less than 275 is less than V of 5. By IVT, V of R will equal 275 on the interval from 1 to 5. Whew.